So now let's talk a bit about deduplication. We've kind of hit around this before in this module and previous ones, but some data just simply doesn't dedupe very well. Databases, that's a pretty common one that we run into. Don't expect to get 10 to 1 deduplication ratios, meaning don't expect a 1 terabyte database to dedupe down to 100 gig. That's pretty unusual. We're pretty happy when we see somewhere around 3 to 1 in a lot of cases, but it depends greatly on what's stored in the database. If it's large tables, we see very good dedupe, unusually good, but often we see things with much less redundant data. And it's not uncommon to see people with databases that have tables that are encrypted or compressed. And if you do either of those, it just kills the dedupe ratio, because anytime you do compression, anytime you do deduplication, it randomizes that data set, and therefore you don't get very good ratios. So be careful with that as well. Sometimes people have to encrypt the tables due to compliance, and there's not much they can do. But compression, if we can get them to uncompress the tables, usually dedupe will get them back to space savings, but better performance. Graphics, like I show there on the right, like JPEGs, they do not dedupe well, simply again because most modern graphic formats have compression built in, which again randomizes the data. Now, if I had 1,000 copies of that Pluralsight JPEG there, they would all dedupe down to basically one of them, but you don't get very good dedupe ratios across different graphic files. Other things dedupe very efficiently. Virtual desktops, that's like the killer use case for these sorts of arrays. If I've got 500 or even 1,000 or really even 2,000 virtual desktops all running the same Windows 8 image, you get just phenomenally good dedupe ratios. Even if you have varying images, often those Windows machines would dedupe very well. This goes well for mixed virtual machine workloads too. Again, hundreds of Windows servers or installs of Windows servers will dedupe down very well. Now, the data between them that may be different may not dedupe as well, but overall you get really good ratios. So that's why you'll see virtual desktops as a lot of the leading use cases for these all-flash arrays, and also it makes it very inexpensive. You can put a lot of desktops on a smaller brick and go in with a cheaper kind of price point. So those do very well, unlike, say, databases or graphics files. What about other services? What if you need something like SMB or CIFS or NFS for Windows servers, Linux servers, things like that? Well, XtremIO only does block. It only does Fiber Channel. It only does iSCSI. So these other services you have to provide with other servers. And it's not uncommon to have like a virtual machine share out capacity off of the XtremIO device to whatever you need. So you may spin up a Windows machine and act like a CIFS server, may spin up a Linux machine and act like an NFS server. It works very well. You still get your dedupe and your performance. You're just not managing those file services on the XtremIO cluster itself. You do that from those virtual machines. And you can also do it from a physical machine. It doesn't have to be virtual. You could have a Fiber Channel physical Linux host or Windows host and do the same thing. What about replication? This is one area that can get a little bit interesting. So as of version 2.4, there is no internal replication within XtremIO. So you have to use some other external means. One common solution is vplex and recover point. So vplex and recover point are EMC replication solutions. vplex is a product that we often use for active data centers, meaning we can put vplex with an appliance in front of storage in a primary and a secondary site and split a VMware cluster or a Windows cluster, something like that, across the two sites. And if one site fails, everything immediately takes over at the secondary site. And it gives you true active storage. Those clusters can access the same data stores or the same volumes from either site. And again, so if site A fails, VMware HA will restart the VMs on site B immediately. You don't have to do orchestration with something like Site Recovery Manager. So vPlex is common for that. It also integrates with EMC's recover point replication, which does great WAN optimization, dedupe compression, and also allows you to do journaling rollback. And if you want those capabilities, you can do vPlex plus recover point in front of your Extreme IO cluster or clusters. If you're in a virtual environment, you have other options. One is a third-party product called Zerto. Again, it does great WAN optimization, does journaling rollback. You can also use the built-in host-based replication HBR that comes with vSphere these days. Not as robust as Zerto, but it's still very usable. If you have a mix of physical and virtual, though, you're going to have to do something else. Virtual, you can use Zerto HBR. Physicals, you'll need to use vPlex or recover point or some other application level replication, at least for now.